Have you ever actually wondered how a hacker gets into a network? Not the movie version, but how it really works. Well, today we're opening up their playbook. We're going to walk through the whole thing, step by step, from just guessing a password all the way to taking complete control.
Okay, so let's get the main definition out of the way. What is network exploitation? Well, you can think of it like digital lockpicking. The real goal isn't just breaking in, right? It's about finding that one path that takes you straight to the good stuff, the crown jewels, the most valuable data on the network.
So here's the game plan. First, we're going to try to kick down the front door. That's all about password attacks. If that doesn't work, we'll listen in at the window, eavesdrop on the network. Then we get clever and start crafting custom keys. And to wrap it all up, we'll look at the one tool that's like a hacker's Swiss Army knife, combining all these techniques.
Okay, let's dive right in. Forget all the super complex movie-style hacking for a second. Where does almost every attack really begin? It all starts with the most common thing you see online, the login screen. That simple username and password box, that's the front gate. And you better believe it's always, always the first thing an attacker goes after.
Right, so how do they get past that gate? Well, there's a whole world of tricks just for cracking that password. Let's dig into how they actually storm the front door. So these attacks basically come in two flavors. First, you have the technical stuff. This is all software, brute force, just pure computing power. But then you've got the non-technical side, which is way more about hacking the person. We're talking about digging through dumpsters for a sticky note with a password, or straight up tricking someone into giving it to you. It's really a battle of brains versus bots. One of the go-to technical attacks is something called a dictionary attack. Now, this isn't about trying every single combination of letters and numbers. That would take forever. Instead, it uses a pre-made list of really common and, more importantly, previously leaked passwords. And here's the crazy part. It works way more often than you'd think. Take the famous Rocky word list. That thing has over 32 million real passwords from just one data breach. And tools like Hydra can just fire them off at a login page one after another automatically. And get this, look how easy it is to actually launch one of these. This one line of code basically tells the tool, Hydra, hey, here's the user I'm targeting, and here's a giant file of passwords. Just go. Try every single one until you get a hit. It's completely automated, and it just does not stop.
Okay, but what happens if the password is just too good to guess?
Well, if you can't brute force your way through the door, maybe you can just snatch the key as it's being used. And that means you've got to start listening in on the network. So, on a local network, a really clever way to do this is with something called ARP poisoning. I love this analogy. It's basically like telling the mail carrier that your neighbor's mailbox is now your mailbox. All their traffic, all their data gets delivered to you first, and they are completely clueless. And that little trick sets up what we call a man-in-the-middle attack. It's this wild four-step dance. The attacker tells the victim, hey, guess what? I'm the router. And then they turn around and tell the router, psst, I'm the victim. Once everybody's fooled, all that network traffic flows right through the attacker, and they can see everything, especially any passwords that aren't encrypted. I know, this sounds super technical and complicated, right? But here's the kicker. Powerful open source tools like BetterCap make this whole thing almost push-button simple. It really is like a Swiss Army knife for this kind of attack, with all the tools you need for sniffing traffic and grabbing credentials already built right in. All right. Let's raise the stakes. What if the passwords are solid and all the network traffic is encrypted? The front door is bolted shut, the mail is sealed tight. What's left? Well, now the attacker starts looking for a secret passage, a tiny crack, a flaw, a vulnerability in the software itself. So let's be clear about what an exploit really is. This isn't just some random attack. The best way to think about it is like a custom-made key, one that's been perfectly designed to fit one very specific, very broken lock in a piece of software. But see, the exploit only picks the lock. It gets you through the door. The payload, that's the important part. That's what you do once you're inside. It's the little package of code the attacker wants to run on the target machine. Maybe it's to steal some files, but more often than not, it's to open up a backdoor so they can take remote control. And you know what's wild? Attackers don't even have to write these custom keys themselves most of the time. There are these huge public databases, like ExploitDB, that are just packed with thousands of known exploits. They can use a simple command line tool, searchsploit, to just look up, say, an old version of a web server, and boom, it'll spit out a list of ready-to-go exploits they can use right away.
Okay, so we've covered attacking passwords, we've covered sniffing the network, and we've covered using exploits. Now it's time to talk about the one tool that rolls all of that into one massive, powerful package. Meet the hacker's ultimate Swiss Army knife, the Metasploit framework. Over 6,000. Just think about that number for a second. That's how many exploits, scanners, and payloads are packed into this single, free, open-source framework. It's why Metasploit is, without a doubt, the industry standard for ethical hackers and, well, the other guys too.
And what's great is how neatly it's all organized. You've got your exploit modules, which are for, breaking in, then auxiliary modules for doing reconnaissance and scanning. Post modules are for all the stuff you do after you've gotten in, and of course the payload modules, which carry that code you want to drop on the target.
Now, the end goal for a lot of these attacks is to get what's called a shell, basically a command line that gives you full control. And you can get one in two main ways. A bind shell opens up a port on the victim's machine and just waits for the attacker to connect. But the really clever one, the one that works way more often, is the reverse shell. This one actually makes the victim's machine call out to the attacker. And why is that so smart? Because most firewalls are looking for sketchy stuff coming in, not going out. So that outgoing call just sails right past the defenses. And actually, using Metasploit follows this super logical, almost recipe-like workflow. Step 1, you pick your exploit. That's the key. Step 2, you tell it who the target is. Step 3, you set your payload. That's what you want to do once you're inside. And step 4, you hit run. Metasploit also comes with this incredibly powerful side tool called MSF Venom. What this does is let you wrap up a payload into what looks like a totally innocent file. Think about it. You could create a payload, disguise it as a Windows executable or even a PDF, send it to someone in an email, and the second they open it, bam, you've got that reverse shell connection calling back to you. This is really where the technical side of hacking blends with the human social engineering side. And really, that brings us right back to where we started. Every single thing we've talked about, from the most basic password guessing all the way up to using a sophisticated Metasploit exploit, it's all for one reason: find a way in and get to the valuable stuff. So that leaves us with one last really big question to think about. This entire playbook we just went through, all these incredibly powerful tools, they're all public. They're open source. Anyone can get them. So in this constant cat and mouse game of cybersecurity, who do you think is actually winning? The attackers who have this playbook, or the defenders who are reading the exact same playbook, trying to stay one step ahead?